I'm going to thoroughly explain the specific differencing method that we are attempting to apply with the primary objective of either completely solving or at least substantially mitigating the complex endogeneity issue.
So to illustrate this concept, I'm going to proceed by using this specific example. Let's consider a scenario where we have a dependent variable, which we'll call y, and it inherently follows an autoregressive path. So in this particular instance, if we're aiming to conduct a regression, it's crucial that we control for the lagged variable. And then let's just assume we have a gamma that accurately reflects the coefficient connecting the current to its previous value. This particular coefficient is generally expected to be less than 1. In an extreme scenario, it might even be equal to 1, but it's far more probable that it will be less than 1. It could represent a ratio, for instance, something like 0.4 or 0.5 and so forth. Now, what we can do here is to first calculate the initial difference, and then we will proceed to compare that result with a more extended or longer difference that we have available. Therefore, in this specific scenario, if we were to compute just the very first difference, the outcome we would obtain would precisely be this particular term. So, within this term, we're going to be calculating the difference of our y variable from the year t minus 1, then subtracting the lagged year's value. This resulting value represents the error. That equation will then provide us with the exact difference between the current y value and the one from the previous year. To put it simply, this represents the immediate difference observed in the shocks, and additionally, we incorporate the anticipated value derived from the preceding difference, which is precisely captured and indicated by the gamma coefficient. So, if you proceed with running this specific regression model, you will certainly face the problem of endogeneity. This arises because, quite simply, the regressor variable R would inherently possess a correlation with the unobserved error term, U. To put it another way, if we carefully break down and analyze the components of this equation, specifically considering the covariance that exists between the observed difference in y and the corresponding difference in the error of shocks, what we will ultimately find ourselves left with is this particular term. This means the lagged y variable is inherently correlated with the prior period's error, precisely because that error forms a component of the current observation. Now, does it truly help if we apply a longer differencing method instead of just doing first differencing? And does it help if we implement a longer differencing? We can perform the calculations, and instead of simply taking the first difference, we could consider taking a fourth difference. In that case, the resulting equation would appear quite similar to this one. Consequently, we have the variable r, which is defined as this particular term, and also the variable u. With these two elements, we can then proceed to calculate the covariance that exists between them. It's crucial to understand and recognize that this specific term, and indeed all other related terms, will ultimately be rendered precisely equal to 0, owing to the fundamental concept of sequential exogeneity. For example, the covariance of a lagged y variable with the future error term, likewise the covariance of a y variable lagged by 5 years with the current error term, as well as the covariance of y lagged 5 years with the past error, a significant 4-year lag in the error term. These values are all expected to ultimately be equal to 0, given that the variable cannot be correlated with any future error.
So in this particular situation, we'll only be left with a single term, this one.
This represents the statistical covariance between the lagged variable y and the error shock that occurred 3-4 years for this current observation. Does that actually have a specific value? Unfortunately, yes, it certainly does. And that particular value is precisely given by this term, or if we consider a minus sign, it would then be defined by this other term. This means that the resulting variance in this particular case would actually be significantly less than what we observe in the initial first difference. This is because we are multiplying by the autoregressive coefficient gamma, which is then raised to the power of 3. It's crucial to recall that the autoregressive coefficient in this situation is less than 1, for example, around 0.5. If we then raise the specific value to the third power, the resulting number will become much, much smaller, significantly less than if this coefficient were not present. So, if you were to carefully compare this particular term, specifically its magnitude, with the corresponding value that we previously obtained here, you would undoubtedly observe a noticeable difference. Indeed, there could potentially be a quite significant discrepancy between the variance of the error, as calculated here, and the value represented by this specific term. The value of this particular term would be considerably less. Therefore, applying a differencing operation, specifically a longer period of differencing, will prove quite helpful, especially if the autoregressive coefficient is not particularly high. So, the error will fade if we use longer differencing, which helps mitigate the endogeneity issue. So, let's go ahead and apply this method using the Finance Research Gate website. I'll be setting it to a single frequency, and that'll be an annual frequency. The reason for this single frequency choice is that both the x and y variables actually share the exact same frequency. Okay, I'll begin our discussion from the year 2000 and finish up in 2024.
The next step will be to carefully examine the market leverage, along with the necessary adjustments focusing on the debt adjustment ratio.
So the X variable in this analysis will represent a factor related to the market debt ratio. I'm also going to incorporate the concept of growth opportunities, which will be quantified using the book-to-market ratio. I'm also going to make sure we control for the specific variable of size, and we will also be controlling for the level of research and development intensity. Of course, we do have a great many other variables available to us. However, to keep this explanation as simple as possible, we'll focus on 3 X variables, and the dependent Y variable will specifically be leveraged.
After we have successfully chosen our X and Y variables, we can then quite easily scroll down the interface. And then it would be beneficial for us to apply lag to the Y variable, considering that the nature of the debt tends to remain quite consistent throughout various periods of time. Therefore, we observe a dynamic relationship at play here. This is because the previous or lagged level of debt leverage, or even just the debt percentage, holds significant power to explain and predict what its future value will be. Consequently, in our model, this lagged Y variable will be incorporated as an independent X variable, meaning we must first generate it. So, first, we'll select our Y variable right here in this field. After that, we'll need to add a single lag to it. This is important because it allows us to properly utilize that lagged value within our X variables. Then, as we typically expect when we scroll down a bit further, we should then be able to identify specifically in this particular instance some clear outliers. So, to effectively manage or resolve that particular challenge, it would be most beneficial to employ a method such as one-zeroization. Therefore, my plan is to proceed by applying the one-zeroizations approach. I am going to apply a single unified approach to all of my X and my Y variables, analyzing them together at the 1% significance level. Now that I've successfully completed all the necessary tasks in this current section, I'll proceed to scroll down the interface to find the Y and X variables. At this point, we are specifically focusing on the one-zeroized Y variable. For the next step, I will be selecting all of the one-zeroized X variables, which will also include the lagged Y. Alright, so from here we'll proceed downwards, and then we're presented with a choice of 2 distinct options. One approach involves performing a long differencing operation specifically applied to a K number, which could be, for instance, 3, 4, or even higher values. Alternatively, our second option is to implement the maximum possible difference that is currently accessible for each individual firm. Alright, let's kick things off by focusing our attention on this particular item here. For our initial step, we'll go ahead and input the number 4 into the system. Therefore, to ensure that this specific area of our interface becomes fully functional and ready for interaction, we simply need to adjust the current numerical setting within this designated input field. And you simply must allow a sufficient amount of time to acquire the ultimate finding. So, in this particular scenario, what we'll be doing is calculating the 4-year difference for every single variable that we have available, and following that, we will proceed to execute the regression analysis. So, instead of simply placing y, for instance, on the left-hand side of our mathematical equation, we will now be using the expression y minus yt minus 4, which represents the 4-year lag of y, and then we proceed to calculate the difference. Similarly, we apply the same method to all x variables. So we're converting each variable into a difference variable, not taking the first difference in this specific case. Instead, we're taking the 4 years difference. Alright, so right here, we can clearly see the results of our analysis. We've got the descriptive statistics, the R-squared value, the F statistics, and other relevant metrics, as you can see. And then down here, we're looking at the estimated coefficients themselves. Now, this specific value represents the coefficient for our difference variable, of course. This is precisely what we refer to as the long difference. And then let's consider this particular coefficient, which I had initially suspected might suffer from an endogeneity problem. However, by applying 4 years of differencing, this potential problem might not present a significant issue. We believe we have successfully mitigated the endogeneity. It's possible it could still exist, but its impact would be considerably less severe than if we applied OLS. Here we have a positive finding indicating that the debt percentage exhibits persistence. This implies that if the previous year recorded a higher value, it is highly probable that the subsequent year will continue to show that same elevated level. Value firms typically employ a higher degree of financial leverage, or put differently, their economic growth intensity isn't quite as robust. Additionally, it's often the case that larger, more established companies tend to carry a greater percentage of overall debt in their capital structure. Now, if we consider the maximum time difference, perhaps for certain companies, we have data spanning 3 decades. Therefore, we will utilize a 30-year differential. Other companies might have a 15-year period, so the specific duration can really vary quite a bit from one firm to another. It truly is a case-by-case situation for each company. So if a firm has the longest duration, for example, 30 years, then we will simply use that 30. For other firms, if their maximum duration is 15 years, we will then take 15, 4, 3, 2, and so forth. So this is not a universal difference, unlike the approach we previously implemented here. The specific values and metrics involved tend to vary quite significantly across different firms. However, for our analysis, we are specifically identifying the absolute longest possible difference for each firm in our current sample. And when we examine the various variables, our overall conclusion remains exactly the same. We find a result that is both positive and statistically significant. This holds true for value firms, which typically exhibit greater financial leverage on average. As generally the case, the larger corporations often utilize a greater degree of financial leverage, meaning they have a higher proportion of debt in their capital structure. So that concludes our discussion on both long differencing and the longest differencing methodologies we've explored today. And thank you very much for watching this presentation.